This video is about networks and the shortest path. We begin by doing a quick revision of some of the terminology. So we have a network diagram, and these diagrams can represent various situations. One of the most obvious is distance between towns or places, but it could also be the cost of laying cable or something similar. The points of the network are called nodes, sometimes called vertices, and we usually represent them with a dot or an open circle. If you have to draw your own diagram, an open circle might actually be more convenient so that you can write numbers in it. Arcs are the edges or lines between nodes, and sometimes they're called paths. Finally, each arc is often assigned a number, which we would call the weight, and that can represent distance, cost, the time involved to complete a project, etc. So let's look at an example. We want to find the shortest path between A and G. So we start at point A, and I recommend circling the part of the network you're looking at. So we circle the node A. Our job now is to find the shortest path to the neighbouring nodes. So we can start with B. The shortest path will be directly from A to B. If we try and go via C, for example, obviously that's much further, so that's undesirable. And because we know the shortest path will be directly from A to B, we should underline that number or highlight it in some way. And we now need to write the number next to the node. If we don't write the length of the path to the node, we're going to probably make a mistake later on. It's important when you're using an algorithm like this one that you follow the steps very carefully. Let's look at C, and we want to find the shortest path to C. I'm trying to connect C back to either of the nodes on my network that are already online. If I go directly from A to C, that will give me a distance of 4. If I try and go from B, that will be 3 plus 4 equals 7. But I hope you can see here that all I need to do is look at this 3 and add the 4 to that, because I've already written the number of the shortest path to B. Once again, the direct path will be the shortest route, so I underline the 4 to show that I've selected that arc, and now I write that number next to the C, and C is now online. Next I will look at the D, and the shortest path is directly from A. Write that number next to the node. What about E? I can connect E from B, C or D. The shortest route will be directly from B. 3 plus 4 equals 7. Notice again that I'm just adding those two numbers to get my total of 7. Let's look at F. I can connect to F from D, C or E. C to F will be 4 plus 5 equals 9. D to F will be 6 plus 7, 13. And if I try and go from E, that will be 7 plus 3 plus 2, which is 12, which is obviously longer than the direct path from C. So 4 plus 5 equals 9. Finally, we come to the final node, G. I can connect from E or F. 7 plus 3 equals 10, 9 plus 2 equals 11. So the shortest path is E to G, and the total path length is 10. Now I can get my highlighter or a different color and backtrack, remembering that I've already underlined the shortest path, so backtracking is easy, and my answer will be A, B, E, G is the shortest path for this network. Shortest path problems can be a little bit more complicated if you have lots of nodes and lots of arcs. Sometimes you have more than one solution, but if you follow the steps of this method, you'll get the answer every time.